Hello, welcome to the channel Just About the Universe, where you and I will explore imaginary topics beyond the universe together. Have you ever imagined a place that everyone considers anti-life inside it, but it actually has another world? I have a question for you. What if inside a black hole there's another world, with different species, different planets, different lives from ours? So let's close our eyes and imagine together, and before doing that, please give me a like and comment the time you're watching so we know we're journeying together. 1, 2, 3. All right, let's venture into the black hole. When we talk about black holes, we often think of them as monsters in the cosmos, devourers of light, endpoints of stars, and the universe's way of saying, you think traffic jams are bad? Try eternal gridlock. The supermassive ones at galaxy centers, like Sagittarius A in our Milky Way, or the stellar remnants left after supernovas, like cosmic confetti from a star's explosive retirement party that no one RSVP'd to. Even when we stretch our minds to the event horizon, that invisible boundary where escape velocity exceeds light speed, it feels like the edge of oblivion, or the ultimate do not enter sign with a beware of dog addendum, where the dog is gravity itself. Yet, for us mere mortals, it already feels like a profound mystery, enough to fill observatories with debates, simulations, and probably a lot of caffeine-fueled arguments. And if you're like me, enough to make you wonder if your keys fell in there too, or if that's where all the odd socks go for their reunion. But black holes are much vaster in implication, old enough to overwhelm us, not billions, but perhaps infinite in their potential, like that one relative who always overstays at family gatherings and tells the same stories. The universe may contain trillions of these enigmatic entities, some as old as 13 billion years, give or take the Big Bang's timeline. For most of cosmic history, they've been silent guardians, shaping galaxies without fanfare, like introverted architects who prefer working from home and avoiding small talk. Matter falls in, spiraling down in a dance of doom. But what happens beyond the point of no return? According to Einstein's general relativity, space-time curves infinitely at the singularity, a point of zero volume and infinite density, basically the universe's version of cramming for an exam at the last minute, where everything gets squeezed into one chaotic note. Yet, though it sounds final and a bit depressing, this is where most of the universe's secrets might be written, tucked away in a cosmic diary that's locked and thrown into the void, layer upon layer, event upon event, in a slow warping and quick forgetting way that makes even the most patient archivist throw up their hands. Imagine deep space-time as a vast canvas, where each black hole is a fold, and most folds are concealed, leaving only faint gravitational waves for us to decipher, where each lost detail is a missed opportunity to understand existence. And if those waves could talk, they'd probably say, "Sorry, we're a bit wavy today," before fading into static. Hawking radiation suggests black holes evaporate slowly over unimaginable timescales, like that ice cube you forgot in your drink that eventually turns into nothing but a wet spot. But what of the inside during this long goodbye? Theories like black hole cosmology propose that our universe is inside one, with the Big Bang as a white hole expulsion, or the singularity birthing new realities, kind of like nature's ultimate recycling program where old universes get turned into new ones with better features. Viewed this way, evidence isn't destroyed, it's repurposed, transformed, perhaps even upgraded. Surviving the horizon is already an extraordinary event, a rebellion against entropy's grasp, or as I like to call it, the cosmic equivalent of sneaking out past curfew and not getting caught. So let's imagine, just as a thought experiment, and hold on to your hats, or they'll spaghettify too. Suppose you approach a black hole, your body elongated like a bad yoga pose gone wrong, but instead of annihilation and a dramatic end credits roll, you cross into another world. Maybe 100 million light years away in some distant corner of the cosmos, long after stars formed but before galaxies matured into their current shapes, an intelligent realm evolved inside this gravitational giant? Perhaps not carbon-based or even matter-bound. Maybe they're just energy beings hosting the universe's longest glow-in-the-dark rave, complete with pulsing lights and no closing time. It flourished, building societies on the fabric of warped time, exploring the boundaries of their enclosed realm. Then something happened. A merger and evaporation, or just the slow fading of gravity, like forgetting where you parked your spaceship after a long night out. It vanished, leaving behind only whispers in the waves, and now we arrive, eons later, asking if we'd know if it was ever there. Spoiler, probably not, unless they left a "We Were Here" graffiti on the singularity or a time capsule that somehow survived the ultimate pressure cooker. Because the harsh truth is realities aren't as durable as we think. They're not built to last like that one pair of jeans from high school. Galaxies merge like awkward family reunions where everyone brings drama, stars explode in dramatic exits worthy of a soap opera, horizons shift like bad hair days that never end. None built to survive cosmic time, leave a universe alone for a few billion years. Entropy reclaims it faster than mold on forgotten cheese in the fridge. A few more, it's hard to see what was there. The details blurred like a photo taken on a shaky hand. But a few trillion years. Hawking evaporation, quantum fluctuations, dissolution, like the universe hitting the reset button after a bad game and starting over with new rules. By then the fabric has changed completely. What was a world might be radiation, scattered like confetti after the party. What was structure might be echoes, faint and fading, and most traces disappear, leaving us to ponder if it was all just a cosmic prank played on curious minds like ours. Think of the Event Horizon Telescope's image of a black hole, a fuzzy ring of light from 2019, looking like a donut that's seen better days, or perhaps the universe's attempt at abstract art. But nature has already started blurring traces, with accretion disks fluctuating like a bad Wi-Fi signal during a storm. Now, scale that to eons. Even gravitational scars could dissolve into quantum foam, becoming a vague anomaly, no longer telling tales of hidden worlds, more like whispering you had to be there before going silent. And if the universe's entropy is the rule, then black holes are its embodiment, where everything, from stars to civilizations, eventually returns to nothingness, a grand cosmic back to square one. This makes us wonder, is our reality an exception, or just a short chapter in the warped book of existence? To expand on this, let's consider the variety of black holes themselves. There are stellar mass black holes, formed from collapsed stars, weighing about 5 to 100 times the mass of our Sun. Small fries in the cosmic scale, but still capable of swallowing whole systems if they get close enough. Then there are intermediate mass black holes, the middle children of the family, perhaps 100 to 100,000 solar masses, lurking in globular clusters and playing hide-and-seek with astronomers. And finally, the supermassive behemoths, millions to billions of solar masses, sitting at the hearts of galaxies like lazy kings on thrones, influencing everything around them without moving a muscle. Each type could potentially host different kinds of worlds. A small one might have a cozy, intimate interior, while a supermassive could be a sprawling metropolis of realities. But no matter the size, the warping is the same, relentless, unforgiving, and oddly democratic, treating stars and planets alike as mere snacks. This variety adds another layer to our speculation. If smaller black holes evaporate faster, their hidden worlds might escape as radiation sooner, leaving behind bursts of information that we could, in theory, decode, like popping a balloon and trying to read the confetti. Larger ones, with longer lifetimes, might hold on to their secrets for trillions of years, allowing complex systems to evolve in ways we can't even fathom. Perhaps in one of these giants, a world has developed technology to harness the singularity itself, turning the point of infinite density into a power source or a portal. But again, Without signals crossing the horizon, we're left guessing, like trying to figure out what's inside a wrapped gift without shaking it too hard. In essence, the scale of black holes reminds us that the universe operates on levels far beyond our everyday experience. It's a place where big and small lose meaning, where time can stretch like rubber and space can fold like origami gone wrong. As we delve deeper, keep in mind that these ideas, while grounded in science, invite us to stretch our imaginations. Just don't stretch too far, or you might end up spaghettified in thought alone. This isn't pure fantasy. It's based on what we know from relativity and quantum mechanics, though if relativity had a sense of humour, it'd be the one telling dad jokes about time flying when you're having fun, and quantum mechanics would be the punster saying I'm uncertain about that. Traces of alternate realities are elusive too, not because worlds don't exist, but because black holes are efficient recyclers, like that friend who turns your old junk into art you don't understand, or worse, art you do understand but wish you didn't. Look at the cosmic record. It's patchwork at best, like a quilt made by a committee of indecisive aliens who couldn't agree on the colours. Not because the universe isn't vast, but because observation conditions are specific. You need the right angle, or it's like trying to watch a movie through a keyhole while wearing sunglasses. Most events that occur don't leave detectable signals. They dissipate into the void, like bad ideas at a brainstorming session that never make it to the whiteboard. They're obscured by cosmic dust or gravity's heavy hand. They vanish faster than your New Year's resolutions in February. To become observable, you need alignment, persistence, and protection from dispersion. Then luck for that signal to reach us, be detected, and be interpreted, preferably before the next coffee break or funding cut. Multiply that challenge by the horizon's barrier, and you start to see the scale of the problem. It's like finding a needle in a haystack. If the haystack was the size of the universe, the needle was microscopic and the hay was on fire. And it's not just signals. Structures, energies, fields, even made from exotic matter, don't last forever. Most particles decay like overripe fruit left in the sun. Most fields dissipate, especially under extreme gravity, like trying to hold a conversation in a wind tunnel during a hurricane. Even space-time, if quantum gravity holds, might foam and reform, bubbling like a cosmic soda that's been shaken too hard and is ready to explode. So if a world existed inside a black hole, especially one not leaving vast gravitational imprints, we might never know, unless they sent a postcard. But postage from a singularity is killer, and delivery is eternal. You might wonder, has anyone seriously considered this? And the answer is yes, with a side of hold my telescope and a dash of pass the popcorn. In recent years, physicists like Nikodem Popłowski and others have explored black hole cosmology, suggesting universes form inside black holes via torsion in general relativity, like twisting a balloon animal into a new reality, complete with party hats. They didn't propose such worlds exist, but asked how we detect them if they did. They called it a model for multiverse nesting, a nod to fractal cosmologies that sound like the universe's Russian doll collection, where each doll has its own little universe inside ad infinitum. Their real question was methodological. What traces would a nested world leave in the outer universe after eons? And could those traces be there, misidentified as something else? Like mistaking a cosmic burp for a profound message from the beyond, or a gravitational wave for the universe's stomach growling. They focused on signs, spin alignments in early galaxies, unusual matter distribution, synthetic quantum states not occurring naturally, like finding a designer handbag in a thrift store, or a gourmet meal in a vending machine. In other words, they think like detectives who find no portal, no gateway, no witnesses, but hope the horizon still tells a story, even if it's the butler did it with gravity, or a whodunit where the culprit is time itself. And in doing so, they raise an uncomfortable possibility. Maybe absence of evidence isn't evidence of absence. Maybe it's just how we look when gravity resets its canvas every few horizons, like a cosmic etch-a-sketch shake after a frustrating drawing. Because worlds don't vanish cleanly, they leave echoes, like that song stuck in your head from a commercial you hate. Energy fluxes, gravitational waves, Hawking radiation all leave fingerprints, but fingerprints fade, especially if the culprit is wearing gloves made of quantum foam or has washed their hands in the river of time. And if a prior world went through a Big Bang equivalent, could we still see the impact in cosmic microwave background, dark matter patterns, or ancient light compositions? Maybe yes, maybe no, like asking if your cat pushed the glass off the table on purpose, or if it was just gravity. This isn't idle speculation. Thinking this way helps physicists test theoretical limits. It's about understanding not just what we observe, but what we might miss, like that plot twist in a movie you slept through because the popcorn was too good. The cosmic record is full of gaps. Some epochs are well mapped, like popular tourist spots with good reviews. Others are almost erased, like bad tattoos you regret. Quantum fluctuations can remove data layers that took billions of years to form, like a cosmic delete button pressed by accident. Gravitational waves can fold, fault, and bury entire regions. Most of the universe's interior is cosmologically young. That means it's been renewed or altered in the last few billion years, like a software update that wipes your history and adds new bugs. Even black hole interiors might recycle through evaporation, turning old realities into new ones like a gravitational thrift shop where everything is as is. That means if an ancient world built anything near horizons or in now warped zones, there's a real chance their traces are now at a singularity, slowly leaking as radiation. Talk about a slow news day or the universe's drip-feed newsletter. And yet here we are now, observing, theorizing, simulating, and occasionally scratching our heads in confusion. We wonder if we're alone in the cosmos, but rarely ask if we're alone inside our own potential black hole. Like being the only kid at a party wondering where the cake is, only to realize it's in the fridge, in another dimension. Perhaps the interior is quieter than we think, or perhaps we've lost the ability to hear it over the noise of our own theories and the hum of everyday life. We'll continue right after this, as we look closer at what might survive, what won't, and whether we've already stumbled upon traces without realizing it, like finding a cosmic Easter egg and thinking it's just a rock, or worse, trying to eat it. In everyday conversation, we think of a world as a realm with matter, life, laws, perhaps planets, stars, societies, and hopefully better coffee than here, or at least a drive-through. But that's a narrow view, like judging a book by its cover, or a black hole by its silhouette, which is basically a dark circle with attitude. Even in our universe, worlds look different. Some are gas giants with diamond rains, others icy moons with subsurface oceans, perfect for ice fishing aliens or a chilly spa day. Yet we still call them worlds, even if they'd make terrible vacation spots with 0 stars on Yelp. It's helpful to think of a world less as a container and more as a spectrum. Between quantum foam and multiverse nesting, there's a lot of room for variety and creativity. A realm sustaining patterns, evolving entities, modifying its fabric intentionally. It doesn't sound like much, but it's huge cosmically, like upgrading from a studio apartment to a mansion with infinite rooms and no mortgage. And if it happened more than once inside black holes or elsewhere, it's worth serious consideration. For example, consider holographic models where information on the horizon projects inward like a simulation. They suggest worlds can exist without traditional matter, expanding the definition to non-physical forms, where reality might be a computational network rather than tangible space. Basically, the universe is a giant VR game, and we're all NPCs wondering if the players are laughing at us, or if we're the ones controlling the controller. Let's look at an example close to home, or as close as black holes get without sucking you in for an unwanted hug. the accretion disk around a black hole, a swirling ring of superheated gas and plasma, like the universe's hottest pizza spinning at relativistic speeds. No solid ground, no life as we know it, yet it's a dynamic system with energy flows, magnetic fields, and particle interactions implying complexity, or at least a really good light show worthy of a Las Vegas strip. Because what's important isn't the solidity, but the pattern, coordinated flows, long-term stability, shared dynamics, emissions. Even without inhabitants, it's evidence of collective behavior across scales, like a flash mob in space choreographed by gravity. Going further back, the earliest evidence of structure in our universe comes from cosmic microwave background fluctuations, implying seeding, growth, perhaps precursors to galaxies from the hot, dense early days. Not modern worlds, but worlds in their own context, proof of fabrics working abstractly, like the universe doodling before getting serious about stars and planets. To make this even more vivid, let's consider hypothetical scenarios. Suppose a hidden world inside a black hole has evolved life forms that navigate time dilation as easily as we navigate traffic. Perhaps they have time lanes for fast and slow living, or imagine societies that use the singularity as a central hub, like a cosmic capital city where all paths lead but none return. These ideas stretch the imagination, but they help us appreciate the diversity possible in such realms. So now imagine a world not billions of years old, but nested inside a black hole for eons, perhaps with its own history of rises and falls. What would we expect to find? It depends a lot on what it was like. If built with quantum fields, strings, brains, exotic particles, those don't last in our detectors, vanishing like promises in politics or diet plans. If they entombed knowledge with rituals but no durable signals, we might find echoes but miss the meaning, like overhearing a conversation in a language made of math or binary code. And if they didn't develop observable emissions or used forms we don't recognize as structure, their stories could be completely lost, poof, like a magician's trick without the reveal, or a firework that fizzes instead of bangs. Worse, if they didn't manifest in observable space-time or spent most existence in environments not good for signal propagation, detection chances shrink faster than your enthusiasm for Monday mornings or a balloon in a vacuum. If a world emerged in high curvature zones, singularities, or firewalls, most relics vanish in instants, let alone eons. It's not hiding. It's gravity playing hide and seek with the rules stacked against us, and gravity always wins. We must also be careful not to project too much. We're used to seeing worlds in forms we experience, 3 dimensions, linear time, matter-energy duality. But worlds don't have to look like ours. A black hole interior might not be expansive. It could be a cozy pocket dimension, where up is a suggestion or a luxury add-on. It might organize reality in ways not leaving large observable marks, like a minimalist artist who prefers blank canvases over busy murals. It might communicate via entanglement or visually through behaviors we have no words for. Imagine texting with quantum winks or sending memes via wave functions. And that raises a strange issue. Would we recognize it as a world? Think of quantum foam. To us, it's chaos, a bubbling sea at Planck scales, like the universe's espresso machine gone wild and over-caffeinated. But technically, it's a marvel. Fluctuations, virtual particles, potential fields. If we didn't know what we were looking at, we might mistake it for empty noise, like static on an old TV or a bad radio station. Scale it up eons or bury it beyond horizons, even those traces could vanish. Leaving us to say must be the wind, or probably just cosmic static. So when thinking about hidden worlds, we need to think like cosmologists and theorists, and maybe a comedian, to lighten the load and keep our sanity intact. We're not just looking for planets, we're looking for patterns, anomalies, disruptions, unexpected entropy concentrations, field changes not matching known processes, odd quantum ratios, things that might suggest something was there doing something unusual, like a cosmic whoopee cushion waiting to surprise us. There's also the question of duration. How long does a world need to last to leave marks? Not long cosmically. Our universe transformed in just 13 billion years of expansion, from hot soup to galaxy buffet with all the trimmings. In black hole interiors, it's just a fleeting warp, but the informational impact is measurable. Entangled particles, holographic encodings, radiation bursts. Even if it vanished tomorrow, some changes would be detectable for epochs, perhaps eons, like a bad haircut that takes forever to grow out, or a tattoo you regret but can't remove. To delve deeper, let's consider the implications for exploration. If hidden worlds exist, our current tools, telescopes, detectors, simulations, might be like using a magnifying glass to study the ocean floor. We need new approaches, perhaps quantum telescopes or AI that can decode the language of gravity. But until then, we're left with speculation, which is half the fun, like brainstorming for a sci-fi novel. So perhaps the better question isn't if a hidden world existed, but if we're asking the right questions to detect it. We look for signs meaningful to us, stars, life, signals. But if the signs are stranger, smaller, or in places we haven't thought to look, like checking your pockets for keys that were in your hand all along, or searching for glasses that are on your head, we'll continue. Because to answer fully, we need to see how black holes behave over long spans, not just seconds or years, but entire cosmic cycles. And that means looking at warping forces, what stays, what fades, and why. And if we're lucky, maybe find a punchline in the process, because laughter is the best way to face the void. Take the example of simulated universes in quantum computers today, surviving mere moments without leaving physical traces, but highlighting that worlds can exist without massive physical traces, making the idea of black hole worlds more plausible, where they might have blended into quantum fabrics to the point of indistinguishability. It's like the universe saying, "You thought I was deep? Hold my beer and watch this trick. Here's another gem to keep things light. What did one black hole say to the other? You're so massive, even light can't escape your charm." If black holes had dating apps, that'd be the pickup line of the century. If you want to hide something forever, you don't need to crush it or evaporate it. You just need to leave it inside a black hole and wait. Not hours or millennia, but long enough for gravity to work. Because black holes don't stand still. They spin like cosmic fidget spinners on overdrive. They merge like corporate takeovers gone wild. They radiate like a slow cooker on low, simmering away eons. And almost everything within them is temporary by default, like fashion trends, viral memes, or New Year's resolutions that fizzle by February. Start with tidal forces, the universe's ultimate stretch routine. Gravity gradients stretch and squeeze, spaghettifying matter into thin streams. Imagine turning into human pasta, but without the sauce or the Italian accent. Particles align, bonds break, structures deform. It doesn't take long for a star to become plasma, then quarks, like a bad makeover show where the after is just a mess. And if those remnants aren't preserved under unusual conditions, quantum stabilization, exotic states, they're as good as gone cosmically, leaving you to wonder if the universe has an undo button, or if it's more of a delete and forget type. Start with tidal forces, the universe's ultimate stretch routine. Gravity gradients stretch and squeeze, spaghettifying matter into thin streams. Imagine turning into human pasta, but without the sauce or the Italian accent. Particles align, bonds break, structures deform. It doesn't take long for a star to become plasma, then quarks, like a bad makeover show where the after is just a mess. And if those remnants aren't preserved under unusual conditions, quantum stabilization, exotic states, they're as good as gone cosmically, leaving you to wonder if the universe has an undo button, or if it's more of a delete and forget type. Gravitational dynamics are another major player, the drama queens of the cosmos. Black holes aren't isolated. They're social butterflies in the cosmic party, orbiting, colliding, ringing down with waves rippling space-time like a bad karaoke performance where the mic feedback is eternal. When they do, they create mergers, grow horizons, perhaps birth new interiors in a grand display of gravitational fireworks. That last process, ring down, is especially important. It means entire realities are gradually pulled and perhaps nested. Anything in them, fields, particles, worlds, twists and becomes part of the singularity, not buried, reshaped like clay in a potter's wheel, gone haywire or a bad pottery class project. The average lifespan of a stellar black hole is immense, 1067 years for evaporation, sounding eternal until you remember the universe's potential heat death in 10-100 years, when even black holes might say, "Time's up, folks, lights out." That means most black hole interiors will be recycled multiple times through mergers and decays. If an ancient world lived near the horizon, or in now-merged zones, there's a real chance their traces are now at a singularity, slowly leaking as radiation. Outer universes last longer, but even they don't keep perfect records. Expansion dilates signals like watering down soup until it's just flavored water. Dark energy accelerates forgetting, like a forgetful friend who promises to call but never does. Quantum decoherence wears them down like sandpaper on wood. Nebulae come and go like fashion trends. Galaxies collide like bumper cars at a fair. Even giant quasars can fade over time, dimming like a flashlight with dying batteries or a star's retirement glow. The solid view from a cosmic perspective is often just the current state of something in flux, like trying to take a selfie during an earthquake or a family photo where everyone blinks. The cosmic microwave background is often seen as a great archive, radiation patterns stacked like echoes of the Big Bang, a snapshot of the universe as a baby. But that archive is missing chapters, like a novel with pages torn out for coffee coasters or used as napkins. There are gaps where fluctuations never settled or were obscured later by foregrounds, cosmic dust, or other interference. Those gaps are called anisotropies, and they remind us the cosmic record is incomplete. It's a patchwork stitched from what happened to survive, with some parts looking like they were sewn by a cat high on catnip. So when asking if another world existed inside a black hole eons ago, the burden of proof is immense. Not that we haven't found their horizons, but the odds of anything surviving that long are tiny to vanishing, like winning the lottery while being struck by lightning during a shark attack in the desert. And even if something survives, it has to be in a place not evaporated, merged, buried too deep, or completely altered, like finding parking in a busy city during rush hour. Look at how we find black holes themselves. Gravitational lensing distorts light like a funhouse mirror that makes everything look funny. Some we only detect through subtle changes in star motions, like spotting a ninja by the rustle of leaves, or a ghost by the creak of a floorboard. Now imagine trying to find something smaller than a hole, a nested world, encoded field, warped realm. Unless preserved in a perfect quantum niche, it's extremely hard to detect. And preservation alone isn't enough. Most cosmological surveys aren't looking for nested intelligence signs. They're looking for matter, energy, dark components, like hunting for treasure, but only digging for dirt or fool's gold. They check cosmic layers for expansion and structure, not societies or realms. And if something doesn't look artificial, if it's not signal-shaped or obviously manufactured, it might not be recognized for what it is. Even when finding something unusual, the first assumption isn't a world. It's natural process, and that's a reasonable bias. Gravity can create complex patterned structures, jets, rings, horizons. Without context, it's hard to say what's natural, what's emergent. A perfect symmetry could be an artifact or a fluctuation. This is part of why black hole cosmology focuses on indirect evidence. Instead of looking for buildings or tools, it asks if a prior world changed cosmic chemistry, or expansion in detectable ways. In other words, not what they built, but their impact, like judging a party by the mess left behind or the hangover the next day. Even that is hard to track because natural events can create similar changes. Volcanic eruptions? Wait, no, cosmic. Big bangs, inflations, phase transitions, all leave fingerprints that could look like nested activity, like confusing a fireworks show for a war or a meteor shower for UFOs. So the challenge isn't just finding evidence, but interpreting it. And that requires humility, not because it's possible, but because completely ruling it out requires more certainty than the cosmos usually allows. We think reality is a straight line with clear boundaries and voids, but the cosmic record doesn't care about straight lines. It cares about curvature, density, evaporation, and entanglement. It rewrites itself constantly, and that means most of what happened inside black holes, most of what was ever structured, said, thought, or evolved, vanishes, not hidden, just dissolved, like sugar in coffee, sweet but gone. We're not done yet. If gravity is good at warping, then we need to understand what resists that warping, what lasts, not just epochs, but entire cosmic ages. So, next we'll look at the types of evidence that might endure and how to recognize them. Not horizons, not singularities, but something subtler, more informational than physical, more stubborn than matter. Think of how cosmic inflation and dark energy are warping our universe today, forecasting our own future, where even the grandest structures might become echoes. And if expansion is a modern warping force, black holes have seen countless ancient versions, from mergers to evaporations, each time twisting the canvas clean with ruthless efficiency, leaving us to ponder the blank slate. To expand this section, let's dive into the mathematical side a bit more, without getting too technical. After all, we're not here to do homework. The warping is governed by equations like the Kerr metric for spinning black holes, which describes how space-time twists around them like a vortex. Imagine if your morning coffee swirl was the model for the universe. Stir too fast and everything gets sucked in. These equations show that inside, time and space swap roles, with time becoming spatial and space-time-like, which is as confusing as it sounds, like walking through a door and finding the room is the hallway. This swap could allow for stable regions where worlds might exist, but it's all theoretical, planning a vacation to a place that might not exist. Furthermore, the forces of warping aren't just destructive, they're creative too. In some models, the intense gravity could compress matter into new forms, perhaps creating exotic particles or even new laws of physics in localized pockets. If a hidden world harnessed this, they could have technology we can't imagine, like gravity surfboards or time loop entertainment systems. But again, without signals, it's speculation, fun but not fact. In summary, the forces of warping are the universe's sculptors, carving out possibilities while erasing others. They remind us that change is constant, and what seems permanent is often just a pause in the grand dance. When people hear black hole interior, they often picture a dark void, a crushing point where physics breaks, like the inside of your wallet after a shopping spree or a closet full of clothes but nothing to wear. But real interiors are rarely like that. They're theoretical, partial, inferred from equations that make your head spin faster than the hole itself. The quantum record is one of our best tools for understanding hidden realms, but it doesn't give a full picture. It's like trying to reconstruct a symphony from a few static notes, a torn score and scattered echoes, or piecing together a concert from audience selfies and half-heard tunes. For every state we model in the interior, there are probably dozens or hundreds that left no trace. Some never stabilized. Some did, but the signals were destroyed in the chaos. Others are still entangled where we haven't probed, hiding like that one sock under the couch or a secret in a locked diary. Stabilization depends on a combination of factors: how and where the matter entered, the type of horizon that forms it, the speed of infall where the quantum effects tunnel the information away like a sneaky escape artist, whether the location is dynamically stable and whether later mergers or evaporations expose the signal without scrambling it into nonsense. That's a lot of conditions, like a recipe with too many steps. The odds are against preservation from the start. And for most of cosmic history, the places where complexity might thrive, near horizons, in accretion flows in warped zones, aren't good for records. They're too active, too curved, too exposed, like trying to write a diary during a roller coaster ride or a rock concert. Now imagine trying to preserve not just particles, but structures, fields, worlds, things that don't even start with the durability of quanta or fields. The odds drop further, like betting on a three-legged horse in a race. Even entangled states, relatively resilient, can be hard to decode and recognize out of context. A qubit could be information or just noise, like mistaking static for a radio hit or a whisper for wind. Without patterns or related signals, it's hard to say. And most informational materials don't survive like fields, fading like ink in rain. So if looking for evidence of past nested worlds, we might only find it if they existed near one of those rare stable zones and then got caught in a preservation-friendly merger. That's a narrow window, and it assumes they left informational remains. Complex worlds, especially if advanced, might handle endings in ways that don't promote record-keeping. Dissolution, transcendence, phase shifts, like a graceful exit stage left. And further, there's a subtler issue. What if the world advanced to the point of no longer leaving classical remains at all? If they entangled into holographic states or evolved into something less local, more distributed, less observable? We don't know if that's possible, but if so, the quantum record isn't just silent. Right now, most theories in quantum gravity are abstract, non-local, or processed to the point they wouldn't register as natural to anyone studying our signals. Eons from now, a future theorist might find a thin entropy layer in a Hawking spectrum. It might raise questions or be dismissed as an anomaly, like, probably just cosmic indigestion, or another glitch in the matrix. Interpretation matters as much as calculation. And that brings up something often overlooked in quantum record discussions. Not just what's preserved, but how we analyze it. We see what we expect to see, and the idea of worlds nesting inside black holes doesn't fit comfortably into most frameworks. So unless the evidence is overwhelming, it's likely classified as natural variation or unexplained anomaly. Not negligence, but because science does that. It favors the simplest explanation that fits the evidence. And worlds, especially hidden ones, isn't the simplest explanation. It's like explaining a missing sock with black hole ate it instead of dryer monster, when the truth is probably under the bed. That's why the quantum record doesn't tell all. It tells what gravity allows to be preserved. It tells what we happen to model. It tells what we're capable and willing to interpret. But it doesn't tell the full story of complexity in the cosmos, and certainly not the full story of nested realities, leaving room for endless debate and perhaps a few good laughs along the way. Still, we have other tools, not just fields and particles, but signals, marks in radiation, horizons, traces not from matter, but from processes. And that's where we go next, into evidence not dependent on quanta, not about particles, but about what happens when something starts changing the fabric it inhabits. When a world leaves fingerprints not through structures or entities, but through information. Remember that quanta aren't just abstract bits, but also invisible impressions like entanglement changes, where complexity has altered the cosmos's balance. For example, in the ring down of black hole mergers, waveform layers show sudden shifts, possibly from internal dynamics or something else, illustrating that the quantum record can tell stories through information, not just form. And if a hidden world caused something similar, it could be mistaken for a natural fluctuation, like confusing a symphony for background noise. To make this section richer, let's explore a case study. The firewall paradox, where quantum mechanics and general relativity clash at the horizon. Some theorists propose a firewall of high-energy particles that would incinerate anything crossing, while others argue for a smooth transition. If a hidden world exists, It might have navigated this by evolving fire-resistant forms or hacking the system, like cosmic firefighters or hackers in a matrix. This paradox highlights the limitations, as our record can't resolve it yet, leaving us with more questions than answers. In addition, the quantum record's incompleteness extends to observational biases. Telescopes like James Webb are revealing early universes, but they're limited by light speed and expansion. We see the past, but not the full picture, like watching a movie with scenes cut for time. This reminds us that our understanding is a work in progress, full of blanks to fill. In recent years, scientists like those exploring black hole cosmology have posed a question that's both wild and grounded in solid theory. They asked, if a complex world existed inside a black hole eons before our observations, would we detect it in the cosmic record? They didn't argue that such a world existed. Instead, they explored how physics would start looking. And in doing so, they named this question a nested universe model. The name nods to ideas where black holes birth new cosmoses, with singularities as big bangs, like the universe's version of surprise its twins, or a never-ending family tree. But the model isn't abstract. It's about testing the limits of relativity and quantum gravity. It's about asking if our universe's structure is unique, or could resemble something much older, hidden deep in gravitational folds, like finding grandma's secret cookie recipe in the attic, or a time capsule from a previous era. The premise is simple, yet profound. If a complex world like a universe developed inside a black hole, say 10 or 50 billion years ago, then vanished or stabilized into something stable, what traces would it leave? And would those traces survive mergers, evaporation, and subsequent quantum disturbances over that time? The scientists start with what we know. Our universe leaves cosmological fingerprints. We change expansion rates with dark energy. We alter dark energy balances. We deposit informational patterns like microwave anisotropies into the fabric, like cosmic graffiti. These global, long-lasting changes are being encoded in space-time right now, a record for future explorers. So the question becomes, which changes are the most durable, and would they look different if created by a nested world than by ours? The models break it down into a few main types of evidence, each with its own flavor. One is informational anomalies, changes in entropy distributions or holographic encodings. For example, universe formation shifts the information balance on horizons. This change is preserved in radiation spectra and wave patterns. If something similar happened far in the past, it could suggest nested processes, even if the world itself is long gone, like finding an old receipt and wondering what party it was from, or a ticket stub from a concert you wish you'd attended. Another type is synthetic states. Complex worlds produce entanglements and fields that don't occur naturally. Many compounds degrade slowly and could theoretically survive eons in some form. Quantum bits have already shown up in the remotest simulations, even theoretical voids. If we found an ancient layer with unnatural superpositions, we'd have to ask where they came from, like discovering a smartphone in a dinosaur fossil or a modern coin in an ancient tomb. Then there's energy use. Nested worlds need dynamics to thrive. If a previous one harnessed gravitational energy, it would release not just waves, but leave ash-like residues, distinct waste in the cosmic dust. These could accumulate in spectra and be detectable, like how we detect merger remnants from ancient collisions, or cosmic litter from a long-gone picnic that the universe never cleaned up. Then phase transitions, the universe's mood swings. Complex activity might accelerate shifts across scales. This kind of signature, sudden drop in symmetry, especially large structures, could leave a clear mark in the quantum record. If something similar happened in the past without an obvious natural cause, like inflation or cooling, it might hint at a nested agent, like a plot twist where the butler was a black hole all along, or a surprise guest at the cosmic party. But here's where things get complicated and a bit frustrating. Many similar signals can be caused by natural processes, mimicking the traces perfectly. For example, The early universe's inflation saw rapid expansion, symmetry breaking, and major entropy disruption. It left some informational fingerprints similar to what a nested world might produce. Yet, as far as we know, no prior world was involved. It was just the universe stretching its legs after birth. So how to distinguish natural events from those caused by complexity? That's the hardest part, like telling identical twins apart when one is a master impersonator, or separating fact from fiction in a tall tale. Black hole cosmology doesn't claim we've found proof of hidden worlds. It asks if we'd recognize proof if it existed. And more importantly, it asks us to think about the traces we're leaving and how long they last. Because even our most durable signals, entanglements, microwave patterns, wave echoes, aren't guaranteed to survive cosmic ages. They could decohere, be buried too deep, or erased by heat death and resurgence. Even if some survive, they might be scattered and hard to interpret without broader context, like reading a book with half the pages in code or a map with no compass. This forces a shift in thinking, a re-evaluation of our approach. Instead of looking for traditional structures, planets, life, we need to think like quantum archaeologists, digging through data with care. We need to seek subtle, indirect clues, informational changes, anomalies in radiation layers, disruptions in entanglement patterns. And we need to be open to some strange features we've already seen in the cosmic record might have alternative explanations, like that cold spot in the CMB being a hello from another world, or just the universe's beauty mark or acne scar. This isn't calling for conspiracy or fringe theories. We're not talking tinfoil hats here. It's a framework for asking better questions, treating the possibility of nested worlds as a scientific hypothesis, not myth or legend, but a testable idea. And like any scientific hypothesis, it can be tested, challenged, refined, or dismissed based on evidence, or laughed at if it turns out to be a cosmic joke on us all. The hypothesis doesn't tell us someone nested before. It just tells us that if someone did, their traces would be hard to find. And it gives us a starting point to think about what to look for, how to interpret it, and what it means, not just scientifically, but how we see ourselves in this cosmos' story as players or mere spectators, and so we move on. If such traces exist, they won't come to us as maps or messages neatly wrapped. They'll be found in spectra, entanglements, thin layers of strange states, requiring patience and ingenuity to uncover. And the real question becomes, have we already found any without realizing what they are? Recently, 2025 discoveries of spin anomalies in early galaxies might relate to natural formation events, but they suggest ways for scientists to further test black hole cosmology, like an example of how new data can revive old ideas and spark new debates. And if these anomalies are natural, they remind us the universe is full of surprises, where the line between natural and nested might be blurrier than we think, and perhaps some natural events in the past are legacies of hidden worlds, waiting for us to connect the dots. Expanding on this, let's consider the role of dark matter in these models. Dark matter, that invisible stuff making up 85% of the universe's mass, could be key to nested worlds, perhaps forming structures inside black holes that we can't see but can infer from gravitational effects. If a hidden world manipulated dark matter, the traces might be in missing mass or unusual clusters, adding another layer to the puzzle, like solving a jigsaw where most pieces are invisible. Moreover, informational traces could include quantum entanglement networks that span horizons, linking outer and inner worlds in ways that defy classical physics. If we detect entangled particles from black hole radiation, it could hint at organized activity inside, like a cosmic telephone line with static on the line. In conclusion for this part, black hole cosmology opens doors to possibilities that challenge our understanding, inviting us to think bigger, bolder, and with a touch of humor to keep from getting lost in the void. If tomorrow you were pulled toward a black hole, no escape, no ship, just falling freely like a leaf in the wind, what would the interior look like a moment later? 100 seconds, a millennium, or perhaps an eternity compressed into a heartbeat. It's a dark but oddly useful thought experiment, one that helps understand the kind of traces a world like ours really leaves inside, and more importantly, how long they last. In the first few instants, not much changes, at least from your perspective. Time dilates for outsiders. You seem frozen at the horizon, like a bad Zoom call on infinite buffer, but for you the fall continues smoothly, perhaps with a view of the universe compressing into a bright ring above, like the world's worst halo or a cosmic crown of thorns. But quickly, without external reference or a GPS signal, the systems supporting your reality start failing. Gravity gradients stretch your body. Particles align in ways they shouldn't. Structures begin to warp. After just a few Planck time quantum effects might kick in with a vengeance. Fields fluctuate wildly. Entanglements form strange loops, like cosmic spaghetti code gone haywire. In a decade of internal time, many particles collapse into the singularity. Waves ring like bells in a cathedral of doom. In an eon, Hawking radiation starts leaking your information outward, but scrambled, holographic, like sending a text with autocorrect gone rogue or a message in a bottle that's been through a blender. Orbital probes, if you had any, start failing as metrics curve and horizons shift. Most will tunnel or evaporate in epochs, leaving only the deepest ones, slowly decohering in silent twist overhead. 10,000 internal cycles later, even those echoes start fading like old photographs. Quantum foam fully reclaims warped zones, bubbling over everything. Singularities perhaps birth new phases, restarting the cycle. What's left depends on spin and charge. Stable orbits might last longer. Think ergospheres or Corchi horizons, regions where physics gets extra weird. But most interior dynamics won't hold up. Go further. 100,000 cycles and almost all entry traces vanish. Only the deepest encodings, most stable firewalls and metric modifications, curvatures, torsions, altered entanglements might still be detectable. But even they fill in or get buried, like hiding your mess under the bed when company comes over. So after an evaporation lifetime, what survives? Not much. Perhaps a few states in radiation spectra scattered like crumbs. Perhaps layers in quantum foam showing entropy spikes, like blips on a radar. These would be the true fossils of entry, not paths, but informational echoes, like leaving a voicemail that's all static and call me back, but no one picks up. If you crossed tomorrow, the interior would start reshaping you almost immediately. No malice, just mechanics, tidal forces, quantum tunneling, metric shifts. All normal gravitational processes would continue uninterrupted like a conveyor belt in a factory. And over time, the idea you were ever there would become harder to prove, like explaining where the other sock went or why the fridge light is on when the door is closed. This isn't just philosophy, it's central to the hidden world question. Because if ours could be warped so thoroughly with all our scale and complexity, how can we expect any earlier world's traces to fare better? It also gives us a benchmark. If something about us lasts, if any informational signature endures, that's perhaps what we should look for when asking if worlds nest inside. Not structures, not entities, but residues, alterations, information, like the crumbs that tell you there was a cookie. And there's another layer to this experiment. Some of our most persistent signs aren't what we carried, but what we changed. Entanglements we formed, curvatures we influenced, isotopes from our decay, phase shifts, redistributed quanta. These aren't paths. They're metric modifications hard to undo, like that stain on the carpet that no cleaner can fix or a dent in the car that's a story in itself. So now imagine you're theorist eons in the future analysing ancient Hawking spectra. You see a thin, strange layer, higher entropy levels, complexity drop, synthetic state traces, perhaps ratios that shouldn't be there. You might ask what happened here, natural or something else. That's where this thought experiment takes us. By imagining our own crossing, we get a clearer sense of what evidence really endures, what rises to cosmic signal, and what sadly just fades away, like a star that burns bright but leaves only darkness. Add details about quantum simulations and digital models in the thought experiment. If you cross with AI data, cloud encodings would dissolve in instants, but some deep holographic projections might leave informational fossils as entangled bits, making the idea of digital legacy intriguing, like an encoded layer in the horizon. And if simulations self-sustain, perhaps part of our complexity survives as code, a digital world without forms, wandering in forgotten metrics, waiting to be decoded by someone or something in the future. This raises questions. Would future observers recognize it as a world, or dismiss it as a natural fluctuation, like we might with ancient signals? Or worse, think it's just the universe's bad code, like a glitchy app that won't close or a virus that thinks it's art. To extend the experiment, suppose you cross with companions, a crew of explorers. Each person's perspective might differ due to relativity, with one experiencing seconds while another ages years. This relativity of experience could mirror how hidden worlds might perceive time, adding a layer of philosophical depth to the scenario. Next, we'll track that signal, what it looks like, where it goes, and how it might be mistaken for something else. Because even if we leave marks, the challenge is recognizing them for what they are. Like finding a message in a bottle and thinking it's just litter. Deep gravity doesn't count miles or parsecs. It works in approximates, events, patterns stretching beyond observation, history, even causality. And if we want to ask if another world might have existed in a black hole's interior, we must learn to think in that language. Because deep gravity doesn't describe what happened nearby. It tells what's encoded in folds. Most of what we know about black holes comes not from direct views but from informational structure. Including gravitational waves, X-ray burst-enst light, and simulated horizons in labs, play pretend for grown-ups with supercomputers. These signals form gradually depending on the dynamics. Matter unfolds in disks like a cosmic carousel. Particles tunnel at edges like sneaky escape artists. Radiation leaks slowly like a dripping faucet. The result is a kind of archive where each pattern gives clues about what the whole was like when it formed, like reading tea leaves. But the tea is space-time and the leaves are quanta. This is the language of deep gravity. And though it doesn't speak full equations, it has vocabulary. Spin parameters, charge levels, mass ratios, wave amplitudes, magnetic orientations. It tells of formations, atmospheric analogues what matter fell, and merger abundance. It even tells of catastrophic events, collisions, evaporations, information losses, and rarely hints at something stranger like a cosmic plot twist or an unexpected guest. Some of the most detailed records come from places where change is slow and preservation good. Quiet horizons, undisturbed mergers, deep quantum layers. Scientists simulate long, cylindrical paths called geodesics and examine layer by layer, bit by bit. They look for shifts, amplitude changes, state content, field presence. Sometimes a phase change is enough to signal a reality shift, like the universe changing channels mid-show or flipping the script. This is where context matters. It's not enough to find an informational signature. It needs to match other evidence. Curvature rise coinciding with phase shifts. Strange states appearing globally, not locally. Sudden heavy field jumps alongside energy indicators. Only by assembling these pieces do we start suspecting something more than random or catastrophe. And even then we're guessing. The deeper in gravity, the fewer reliable tools. Many dramatic events happened billions of years ago. Any clues they left have been curved, folded, buried, and exposed multiple times. Metrics endure, but they change too. Signals get scrambled, layers vanish. Nothing is clean, like a crime scene after a party or a kitchen after baking with kids. Yet some signals are stubborn, clinging on like that one friend who won't leave the party. There are parameters that evolve so slowly they timestamp eons. There are orientation changes matching known cycles in cosmic fields, giving us a kind of gravitational calendar, like marking birthdays in stone. There are states forming only under specific conditions, density, spin, or quantum environments. These are the phrases, the punctuation in deep gravity's language. If a world influenced the interior strongly enough, and in the right way, its impact could show up here. But the hard part is recognizing them. Right now, scientists occasionally find unexplained anomalies, spikes or shifts not matching known events. Most eventually attribute to natural causes. Some remain unsolved, sitting quietly in literature, neither dismissed nor pursued, not because they are unimportant, but because without more context, there's not much to do. Science needs patterns, not just points. And that's perhaps where hidden world traces sit. Hidden in plain sight, mistaken for natural events, like a spy in a bad disguise or a chameleon on a rainbow. If the signature is short or faint or local, it might not raise alarms, or attributed to something like merger ringdowns or radiation bursts or sudden metric shifts caused by quantum changes. All known phenomena, all happened multiple times. Saying intelligence did this is a bold claim, requiring not just anomalous data, but a framework explaining why intelligence is the most likely source. Without that, even a true hypothesis might be overlooked, like ignoring a diamond because it looks like glass or missing a masterpiece in a garage sale. So deep gravity's language is real. It's in metrics, information, the slow rhythm of horizons and entanglements. It tells what changed, roughly when, and often how, but not always why. That part requires interpretation, inference, sometimes imagination, and a pinch of skepticism to keep it grounded. And in that interpretive space, the hidden world question continues to sit, unproven. Perhaps unprovable, but not impossible. And perhaps in the future, with more advanced gravitational detectors, we'll hear those whispers from the interiors clearer, signals currently too faint to recognize. For example, modern LIGO upgrades are helping us read this language in more detail, opening possibilities for detecting anomalies previously missed, and maybe one day, we'll find patterns suggesting nested worlds, like finally understanding a foreign joke after years of confusion, or decoding a message that was there all along. One of the most persistent signs a world might leave isn't structure or matter, it's information. When processing quantum states, synthesizing fields, harnessing gravity, or altering holographic encodings, we change the cosmos in ways written into spectra and waves. These changes are often abstract but widespread, and when they happen fast or globally, they leave sharp signatures, like a tattoo that's hard to cover up or a scar with a story. Let's start with synthetic states. Modern theories produce an astonishing variety of phenomena that don't occur naturally. Superpositions, entanglements, exotic vacua, like the universe's secret spice rack, full of flavors we can't taste. Some decohere quickly when exposed to metrics or firewalls, like ice in the sun. Others are remarkably persistent, especially when holographic. Quantum bits, for example, have shown up in the remotest simulations. Some studies suggest they could remain coherent for epochs in the right conditions. But even states have limits. Left near singularities, they collapse. In stable horizons, they might last longer, but become harder to detect. And a state alone doesn't prove a world. A strange superposition layer might raise questions, but without context. Without evidence of intentional encoding, it could look like an odd natural fluctuation, especially if everything else is gone, like finding a puzzle piece that doesn't fit any box. Then fields. We think fields are durable, and they are, but only in the right circumstances. Most fields fluctuate over time. Gauge fields dissipate. Even scalar fields resistant to decay don't last forever, like a battery that eventually dies. Field configurations can endure a few epochs if left undisturbed in low curvature zones. But eons, unlikely, unless sealed in highly stable settings, say in supersymmetric pockets or deep interiors, not many chances they'll survive intact, and even then, they're hard to distinguish from natural vacua unless the pattern or symmetry is clear, like confusing a painting with a blank canvas. Radioactive analogues are different. Some are synthetic, created only through high-energy reactions, including states like certain qubits or transentangled particles not occurring naturally in significant amounts. If found in the cosmic record outside known events, they could suggest complex activity. But most have short coherence times enough to decohere to background levels over eons. Still, some like long-lived entanglements or topological defects are persistent enough that traces could remain in the right conditions, like that one party guest who won't leave even after the music stops. Energy harnessing is another possibility. Burning gravitational potential releases waves with a distinct signature, specifically altered amplitude to frequency ratios. If this kind of change appears suddenly and cosmically in ancient spectra, it could suggest large-scale processing. But again, natural processes can cause similar patterns, including mergers and inflations. We need additional clues to support a technological source, like a Made by Worlds Inca label. Another possibility is unusual concentrations of certain states like exotic matter, or rare quantum numbers often used in advanced models. Generating and refining these live waste. If found at high levels in ancient encodings or waves, especially patterns suggesting processing rather than natural distribution, they could be evidence of complexity. But these states move through systems in complex ways. They tunnel, they decohere, they migrate. Isolating the source isn't easy, like tracking a rumor in a crowd. What about physical structures? Large, deep metrics, things like stable orbits, Cauchy horizons, or underground analogues, might last longer than transient states, especially if altering local gravity. But recognizing them after cosmic ages is hard, especially if tectonic forces shift or bury the area. Fluctuations, collapses, and radiation can erase even major features, and without clear artificial symmetry, it's hard to distinguish an encoded realm from a natural pocket, like confusing a basement with a bat condo or a palace with a cave. Holographic encodings are surprisingly durable, and some forms actually get stronger over time due to boundary effects. Ancient ADS CFT models, for example, have survived theoretical scrutiny over decades. Modern formulas might last longer, but exposure matters. Curvature, phase changes, and quantum noise all take a toll, and in deep gravity, even encodings might become unrecognizable, just a strange pattern in spectra, like a message that's been through too many translations. Topological defects and glass-like states fare better. They're stable, and ancient defect networks are often among the most persistent cosmic artifacts. In the right conditions, defect fragments could last eons, especially if buried and not exposed to decoherence cycles. But a fragment alone tells little. It needs shape, pattern, or presence in quantities unlikely naturally to suggest artificial origin. Like finding a mug that says, "World's Best Dad" in ancient dirt, or a defect that spells "hello" in Morse code. Then there are indirect signals, changes to dynamics, information webs, or metric chemistry. Modern simulations transform landscapes. They compact data, deplete resources, alter evolution patterns. Irrigation analogues change flow chemistry. Computations leave residues. Expansion and processing reduce diversity. Even after abandonment, these impacts linger. In metric records for epochs, perhaps ages, not enough for deep gravity but more than most artificial states, like the ghost of a simulation haunting the code. All this means if a past world existed, the most durable traces are likely subtle. Not monuments, but patterns. Not entities, but anomalies. Something in spectra that doesn't belong. Disruptions in the slow natural rhythm. And those traces must be found, recognized, and interpreted correctly. No small task when working with gravity older than most galaxies, like reading a book in a language you barely know. Meanwhile, non-durable traces surround us now. Data, simulations, theories, the content of our inquiries. They go first, bits flip, fields collapse, digital signals fade when coherence cuts. Our entire digital culture could become a blank spot in spectra, known only through other informational changes from when we pondered, like the internet going poof, leaving historians to guess from memes carved in stone or encoded in waves. So we return to the question, what endures? Not much, but perhaps enough. Enough to leave a mark, if not a story. Enough to make someone one day pause and wonder. Not exactly what it was, but if something was, and if gravity, despite all it warps, keeps a few stubborn signals hidden in its slow, silent archive. Perhaps in some cases the most enduring trace is metric changes. If a hidden world intervened in fabrics, they might still exist in today's gravity DNA. A hidden legacy in the cosmos's bloodstream. For example, if they twisted spins or edited states, those mutations could propagate through expansion, becoming part of modern dynamics we take for natural, like a whisper from the interior in this gravitational code of waves and fields around us. This raises intriguing possibilities. Could some natural traits in current cosmology be engineered by lost worlds? Like inheriting a family recipe with a secret ingredient you never questioned. To expand, let's consider hypothetical enduring artifacts. Suppose a world created eternal encodings using topological knots, structures that can't be untied without breaking the fabric. These could survive as defects in space-time, detectable as anomalies in waves, or perhaps they left messages in radiation patterns like cosmic Morse code. But again, interpretation is key. What we see as noise might be a symphony. The ocean doesn't preserve secrets. It dismantles them with the patience of a master thief. It scatters, buries, scrapes them away, like a beach erasing footprints with each wave. For a civilization living near or interacting strongly with the sea, this might not seem threatening at first glance. After all, water sustains life, connects continents, provides food, transport, inspiration. It's the planet's lifeblood. But when it comes to preservation, especially over millions of years, the ocean is an unrelenting editor, erasing nearly everything it touches, like a wet napkin to a whiteboard or a delete key on a watery keyboard. Still, it's worth asking, if a technological civilization once existed and interacted meaningfully with the ocean, what kind of marks would it leave? And would those marks pass the deep time test, surviving the relentless churn? Start with basics. Today, most major cities are built near coasts. Fact. Access to trade, resources, mild climates, and that ocean view premium. But it also makes them vulnerable. Coasts shift like moods. Storms erode with fury. Sea levels rise and fall like tides on steroids. And geologically, oceans move dramatically, like the tide that always takes your sandcastle, no matter how fortified. Over the last 20,000 years, sea levels rose more than 100 meters, flooding entire continental shelves and turning dry land into underwater real estate. In past ice ages, vast areas now underwater were dry land, with rivers flowing, forests growing, and perhaps civilizations thriving. Now those areas are submerged under sediment and salt water, hard to access and almost impossible to study comprehensively. This makes finding any ancient civilization that lived along ancient coasts inherently difficult. Not because such a civilization couldn't have lived there, but because those very areas have been erased, buried, or made inaccessible. Underwater archaeology is challenging at best, diving with gear, dealing with pressure, visibility low as fog. Doing it on submerged continental shelves buried under post-glacial sediment is another level, like digging for treasure with a spoon in a haystack that's also a swamp. Assume a past civilization developed maritime technology, not just boats, but ports, harbours, perhaps coastal infrastructure like docks or lighthouses. What happens to those structures over deep time? Wood decays into mush, ropes rot like forgotten fruit, Stone crumbles under waves, metals corrode fast in saltwater environments like rust on steroids. Unless the structure is quickly buried in mud or sand in low oxygen conditions, little chance it survives more than a few thousand years, let alone millions. And even if it survives, it's almost undetectable without high-resolution scanning targeted there, like finding a needle in a haystack that's underwater and moving with currents. Theoretical artificial structures could leave geomorphic marks, straight lines, unnatural angles, repeating patterns in seabed topography, like underwater crop circles. But nature can create surprisingly geometric features. Waves carve, currents sculpt, volcanoes build. And most underwater anomalies, once investigated, turn out to be natural formations like rock outcrops or coral reefs. Without context or artifacts, it's hard to argue otherwise, like seeing a rock formation and thinking it's Atlantis, when it's just a rock having a good day or posing for tourists. Now think bigger and deeper. If the civilization wasn't just near the ocean, but used it heavily, perhaps waste disposal or energy production, would that leave signals? Modern humans have left clear geochemical fingerprints in the ocean. There's giant floating garbage patches, mercury and lead pollution in deep-sea fish, radioactive isotopes from mid-20th century weapons tests, fertilizer runoff signs causing dead zones near coasts and microplastics found at the bottom of ocean trenches, carried there by sinking currents and marine life, like the ocean's version of "you left your trash, now it's my problem," with particles hitchhiking on plankton. Some signals could last tens of thousands of years, especially buried in sediments where time moves slowly. If an ancient civilization introduced synthetic compounds or changed ocean chemistry on a large enough scale, those changes might be detectable today, but subtle and sneaky. And even if found, they must be distinguished from natural processes, hydrothermal vents spewing minerals, volcanic activity adding chemicals, organic matter decay creating layers, all leaving their own complex chemical signatures like nature's forgery or a confusing cocktail. This is the essence of what you might call the lost technology test. Could the technological activities of a long-vanished civilization survive in a way that's still readable today? And if so, would we recognize it as artificial or classify it as unexplained anomaly or worse? Ignore it entirely, like finding an old phone in the sand and thinking it's a fancy shell or a weird rock. Consider synthetic molecules. So, modern plastics and industrial chemicals don't exist naturally and are highly resistant to degradation, stubborn as a stain on your favorite shirt. Some, under certain conditions, could last hundreds of thousands of years. Buried in anoxic seabed sediments, fragments or residues might survive. But again, the challenge is scale. One piece means little, like a single puzzle piece. A widespread pattern means more, like the full picture. And patterns are harder to find than artifacts. They require data across regions, depths, and timelines, something that's only starting to happen in ocean science today, like mapping the sea floor and realizing it's more mysterious than your browser history or a teenager's room. Then there's heavy metals and rare earth elements used in electronics and industrial processes. These elements are mined, concentrated, and often discarded like leftovers from a meal. In theory, unusually high concentrations in sediment layers could indicate processing or pollution. But many of these elements occur naturally in volcanic and hydrothermal systems, blending in, and distinguishing artificial enrichment from natural isn't always clear. You need ratios, context, and an understanding of exactly what natural baseline levels were then. Like being a detective with a blurry photo and no fingerprints. Even deep-sea mining leaves ambiguous marks. Modern deep-sea mining is proposed to extract manganese nodules and other precious resources, like treasure hunting in the abyss. If something similar happened far in the past, the only clue might be altered sediment composition, disturbed layers, or absent expected minerals. But how to detect absence, and how to prove it was technological? Like accusing someone of stealing air or missing shadows. Energy use is another angle. any civilization reaching a certain complexity likely consumed significant energy, like a teenager with gadgets, leaving waste, heat, emissions, and byproducts. In humans, that includes carbon dioxide, industrial gases, and thermal pollution. In oceans, that includes warmer water near industrial zones, changed currents, and chemical outflows. If a past civilization used energy sources producing durable byproducts, radioactive materials, synthetic chemicals, some might be detectable in ancient sediments, but again only if widespread or concentrated enough to stand out, like a spotlight in the dark or a sore thumb in the sea. The problem isn't that these marks couldn't exist. The problem is, even if they do, they don't immediately scream civilization. They look like chemistry, like anomalies, like strange blips in a data set full of natural variation, and unless accompanied by something clearer, geometry, repetition, tools, or obvious construction marks, they remain unsolved. Just noise in the planet's long, slow signal, like a radio station playing static with occasional hits, or a symphony of waves with no conductor. So the lost technology test is a real challenge, not about whether technology existed, about whether the right combination of materials, processes, and environments could allow even a sliver of that technology to be found after tens or hundreds of millions of years, and whether anyone would know what they're looking at if they did. Recently, discoveries like artificial coral reefs or underwater structures in the Mediterranean Sea might be ancient civilization traces or natural, illustrating the ambiguity in identifying ocean marks, where the line between artificial and natural is blurry to the point of disbelief. And if the ocean continues changing due to modern climate change, potential traces could be erased further, reminding us that this process is happening now, and perhaps we're self-erasing our legacy before anyone has a chance to find it, like drawing in sand at low tide. This ties back to the bigger picture. The ocean, covering most of Earth, might hold the key to lost civilizations, but its dynamic nature makes it the ultimate eraser, where waves and currents rewrite history daily, page by page. Next, we turn from the sea to stone, from what's buried by water to what's sealed in rock. Not myth, not metaphor, but materials, things with shape, weight, and texture. Some ordinary, some strange, and some raising enough questions to keep this ancient idea alive. When scientists study rock layers, they often look for patterns, clear sequences helping explain what Earth was doing at a specific time. Warm or cold climate, volcanoes erupting like popcorn, oceans rising like a bad mood. What life existed, thriving or struggling. Each layer like a data point, a page in the planet's diary written in minerals and dust with occasional doodles. But sometimes they find something that doesn't fit, something out of place or out of time. These are called anomalies. And though most eventually get explained, some linger on the edge, waiting for new tools or ideas to make sense, like that one sock in the dryer that defies logic or a plot hole in your favorite show. Not all anomalies are mysterious. Geology is full of odd but natural formations, including minerals that sparkle, strange fossils that look alien, complex layers caused by environmental changes like a mood swing. But occasionally something defies easy classification. A piece that looks manufactured, like it came from a factory. Composition not matching the surrounding matrix, like a puzzle piece from a different set. An object embedded in rock that looks too uniform, too shaped, too intentional, like finding a smartphone in a dinosaur bone or a watch in ancient ice. Take the famous artifacts in coal cases, mostly from the 19th and early 20th centuries, when mining was like digging for gold but finding surprises. Miners occasionally reported finding metal objects in coal lumps, sometimes chains, other times bells or carved stone fragments that looked out of place. These claims are often poorly documented with few surviving samples and unclear origins, like urban legends passed around the campfire. Skeptics rightly point to chaotic mining conditions. Coal seams can crack, collapse, mix with modern debris, and confirmation bias might factor in. People see what they expect or want to see, like shapes and clouds. But the stories persist not because they prove anything, but because they highlight the kind of signals people think to look for, like geological Easter eggs. Then there's the metal spheres found in South African mines, often cited by fringe theorists as evidence of ancient tech or alien visits. These small grooved objects embedded in Precambrian rock over 2 billion years old, older than most life forms, but research shows they're likely natural concretions formed by mineral accumulation under high pressure, like nature's marbles. The grooves could be from natural deformation, not carving. Interesting, yes, but a few remain unsolved, not proven artificial, just unresolved and teasing. And that's the key point. The scientific process is cautious, like a cat approaching a cucumber. It doesn't jump to conclusions. It favors known mechanisms over unknown, and it demands repeatable evidence, not one-off curiosities that can't be replicated. So even if something strange is found in ancient rock, the first questions are always the same. Could it be natural? Contamination from modern times? Layer disturbed by geology, sample confirmed by multiple methods like double-checking your work. Unless all answers are clear, the anomaly stays in limbo, like a plot hole in a movie or a cliffhanger without a sequel. Still, not all anomalies are physical objects you can hold. Some are chemical, invisible but telling. Take isotope excursions, sudden global changes in certain element ratios like carbon or oxygen, shifting like mood swings. These show up in rock layers as sharp geochemical shifts. Most have known causes: massive volcanic eruptions spewing ash, methane releases burping from the earth, or asteroid impacts slamming like cosmic bowling. But the mechanisms aren't always fully understood, leaving room for debate. Some events show rapid heating marks, ocean acidification, and extinctions, all packed in a thin geological slice, like a sandwich with too much filling. Some scientists compare them to what we're doing now with industrial emissions, and a few quietly ask if such patterns, if found far in the past, could ever indicate intelligent activity, like a chemical who'd unit with no suspects. The answer is usually no. Not because it's impossible, but because there's no reason to jump to that conclusion. Intelligence isn't needed to explain most geological events. Nature is creative enough. But if an anomaly can't be explained by any natural process we know, if a layer has a chemical signature matching industrial processes exactly, synthetic molecules, stable isotope ratios, rare metals, global distribution and no volcanic or astral source, that would be harder to dismiss. But we haven't found it. Or if we have, it's sitting in some database labeled anomaly, waiting for the right question, like a forgotten email in your spam folder or a treasure map in a junk drawer. It's also worth remembering many discoveries come not from looking for something specific, but from paying attention to the odd and refusing to dismiss it, like noticing a weird noise and finding a leak. Plate tectonics, for example, was once fringe, laughed at like a bad theory. So was the idea of asteroids wiping out dinosaurs. A rock from space? Sure. The data was there for decades, but didn't make sense until someone connected the dots, like a eureka moment. Anomalies mean something when someone takes the time to see what else they might say, like that aha in a detective story or solving a riddle. And that's where it ties back to lost civilizations. If any marks exist, they might not be dramatic like pyramids. They might not be engravings or artifacts that shine. They might be subtle, unusual mineral deposits, strange metal distributions, synthetic molecules embedded in ancient layers. Alone, they don't say technology, but together they could raise the possibility, like clues in a treasure hunt or dots waiting to be connected. There's also the possibility we've found some of these, but interpreted through the lens of what we expect to find. Geological patterns looking like natural weathering results, layer structures dismissed as sedimentary quirks, geochemical spikes explained by major eruptions or methane bursts. And most of the time that interpretation is probably right. But what if in rare cases it's not? like mistaking a masterpiece for a finger painting or a signal for noise. We don't know what a true ancient civilization's rock record would manifest as. We don't know how long their traces would last, but we know what lasts. And in those lasting things, anomalies, residues, unexplained patterns, any signal, however faint, must live. So we keep looking. Not with hopes of finding buried cities, but with the quiet possibility of finding marks not just in stone or metal, but in genes, sediments, isotopes, patterns not matching natural processes, but not screaming machinery. Perhaps some anomalies, like the strange stone structures at Göbekli Tepe, suggest that even in recent history we're still uncovering surprises, and deep time might hide far more. Göbekli Tepe, with its 12,000-year-old carved stone pillars, was once considered an anomaly, but now it rewrites human civilization history, proving anomalies can change how we understand the past, and perhaps in deeper rock layers, the Göbekli Tepe of millions of years ago await discovery. This encourages us to question our assumptions, as each anomaly could be a key to unlocking hidden chapters in Earth's story, or at least a good story to tell at parties. Next, we step further into that uncertainty. Because not every intelligent culture develops the same way, not every civilization chooses stone or metal, and if some never did, their relics, if they exist, might be so subtle we've walked past them, unnoticed, unmarked, but not entirely gone. When we envision civilization, we tend to imagine certain things: tools, buildings, machines, writing, monuments, and almost all made from or shaped by metal. That's the basis for how we define technological progress. Stone Age, Bronze Age, Iron Age, like levels in a video game. But that framework assumes one path, one model, one ladder to climb, and it's easy to forget metal isn't required for intelligence or even complexity. It's just what we used, like assuming all meals need forks when fingers work fine, or all music needs instruments when voices suffice. So what if another civilization never reached for it? If it evolved, thrived, and vanished without ever extracting metal from rock, or forging it into tools? The idea isn't far-fetched or outlandish. In fact, most of human history, we lived without metal dominance. Early humans made stone tools, built with wood and bone, used fire for warmth and cooking, understood animal behavior for hunting, made clothing from hides, decorated homes with pigments, and developed rich oral traditions full of stories and wisdom. All without melting a single ounce of ore or dealing with rust. Many indigenous cultures continued to thrive with limited or no metalwork, even after contact with those who had, relying on natural materials and ingenuity. Complexity doesn't start with metallurgy. It just becomes visible to archaeology in certain ways because of it, like the difference between a whisper and a shout or a shadow and a solid form. So if considering the possibility of pre-human or non-human civilizations, it's worth asking, what would their record look like if they never entered a metal age? The short answer is extremely hard to find, like searching for a ghost footprint. Organic materials, wood, plant fibers, animal skins, even bones, decay fast unless preserved in extreme dry, frozen or anoxic environments, like nature's deep freeze or vacuum seal. Textiles rot into threads of nothing. Wood burns or decomposes into soil. Anything exposed to moisture, heat, or biological activity breaks down, like leaving your picnic out and coming back to ants' paradise or a compost heap. Even when preserved by luck, organic remains are rarely interpreted as technology, unless showing clear shape or pattern that screams, made by hand. A bundle of fibers could be rope for binding, or just roots tangled naturally. A hollowed log could be a canoe for rivers, or just a log hollowed by decay. Now imagine a hypothetical civilization built entirely from biodegradable materials, eco-friendly before it was cool, shelters woven from plant fibers like giant baskets, tools from hard wood carved with stone, containers from gourds or hide sealed with resin. Decorations, clothing, symbolic writing, all made with natural pigments, feathers, bark, sand, smoke signals. No mining for ore, no smelting fires. Nothing to rust or shatter into durable fragments, like a zero-waste society that the planet would applaud if it could. In the right climate. Dry, stable, protected. That society could last thousands of years and leave almost nothing we'd recognize in the geological record. Forests could grow over it in decades, reclaiming the land like nature's makeover crew. Erosion takes the rest, washing away evidence like rain on chalk. And in millions of years, no trace remains, even of fire, one of the oldest and most transformative technologies that lit the way for humanity. You might find charcoal layers, ash scatters, fire-cracked rocks, but they're common naturally. Lightning strikes sparking blazes, wildfires raging across landscapes, volcanic activity spewing heat. All leave similar marks, black and charred. Distinguishing intelligence use fire from force of nature cause requires context. Hearths arranged in patterns, tools nearby, related artifacts. Without those, just another black layer in soil. Like blaming every scorch mark on cavemen or arsonist squirrels, some non-metal tools might survive, especially stone ones that endure. But not all stone tools are obvious or flashy. A pebble used to grind grains or soften fibers might never be shaped beyond nature's work. A sharp stone used for cutting might not be retouched or refined. If tools aren't curated, kept, stored, reused over generations, they blend into natural background, looking like any rock. And if used in ways not creating lasting wear patterns, they're almost unrecognizable after time, like a rock that's just rocking its natural look. There's also the possibility a civilization reached high understanding, astronomy charting stars, agriculture tending fields, even medicine healing with herbs. Without heavy industry or metal, knowledge isn't always tied to material excess or shiny things. Societies might map stars with naked eye observations and memory, track seasons with stone or wood markers aligned to solstices, or breed plants through careful observation and selection, like early geneticists. They could tell time with water clocks or sundials, calculate with knots on strings or beads on abacuses made of bone, transmit knowledge through encoded songs, dances, or oral epics passed down. Nothing in those systems requires metal, just continuity, community, and creativity. And if that continuity breaks, by natural disaster flooding their lands, disease sweeping through, migration forced by climate, knowledge can vanish as fast as tools decay, like oral history lost in a game of telephone gone wrong, distorted until unrecognizable. Language is especially fragile, like a bubble in the wind. Spoken words vanish with the speakers, dissolving into air. If not written or carved into something lasting, they're gone completely. And even written records can fade away. Paper burns to ash. Bark and leaves decompose into mulch. Inscriptions in sand, dust, paint, or wood don't last unless intentionally preserved in caves or bogs. So if a civilization didn't develop durable writing, or didn't need it, relying on memory and song, we might never know it existed, like the world's best story never told, or a hit song that's only hummed. Then there's the scale question, adding another twist. Not all civilizations build cities that pierce the sky. Some remain mobile, nomadic like winds. Some blend into ecosystems, living in harmony. Some value impermanence, building temporary structures. Our definition of advanced biases toward those leaving big footprints. Architecture that stands tall, pollution that lingers, energy used that scars. But those are cultural choices, not inevitable steps or requirements. And societies could be technologically sophisticated, philosophically advanced, and still choose ways of living minimizing geological impact, especially if learned through experience or catastrophe, that high-impact lifestyles lead to collapse or imbalance. In that case, what marks remain? Perhaps modified landscapes, terraced hills for farming, diverted rivers for irrigation, plants growing far from origin points due to cultivation, perhaps signs of fire management to prevent wildfire, soil enrichment with organic methods, or intentional biodiversity patterns to sustain life. But those are subtle, whisper-like. They blend into natural processes and easy to overlook or interpret as random, like seeing a garden and thinking nice weeds or a forest and missing the managed paths. We've seen this in our own world, with examples that intrigue and puzzle. Amazon terra preta, black fertile soil enriched by ancient communities through char and organic matter, is still not fully understood, a mystery in dirt. It contains charcoal, bones, pottery shards, and layered organic matter in ways suggesting intentional technique, like a recipe for super soil, but it doesn't look like a city with towers. It looks like soil, ordinary dirt. And for long, it was dismissed as just another soil type, nothing special. Only now researchers starting to recognize it as perhaps the legacy of complex societies organized with deep agricultural knowledge, landscape control, and sustainable practices that modern farmers envy. If something similar happened 100 million years ago with less pottery, fewer tools, and entirely biodegradable structures, it might never be noticed, especially if it happened in areas now underwater, eroded away, or subducted into the mantle, like the ultimate out of sight, out of mind, or a secret buried too deep. So non-metal civilizations might not vanish because of failure or weakness. They might vanish because of success in living lightly, blending with the environment, valuing cycles over monuments and legacy over footprint. And from a preservation perspective, that success becomes invisibility, a cloak of time. We think progress as leaving marks that endure, but the absence of those marks isn't always absence. Sometimes it's a choice or consequence of different priorities, or just the result of time never promising to keep our records in the first place, like a library that burns its books. Look at modern sustainable communities in Iceland or Bhutan today, where they prioritize harmony with nature, minimizing traces and impact, like a modern model for what a non-metal civilization might look like. There, civilization isn't conquest or domination, but companionship with the land. And their legacy might be ecological balance rather than stone relics or metal monuments. A lesson for us in the age of climate change, where progress might need redefining to include sustainability. This challenges our anthropocentric view, suggesting intelligence could thrive without the material excess we associate with advancement, and perhaps such civilizations were more common than we imagine. Their silence a testament to wisdom rather than extinction or failure. Next, we look at the silence they all leave, not just physical voids, but deeper uncertainty. Because even with all we know about geology, archaeology, and history, there are places nothing speaks, and that silence might be telling us something or hiding what was once there. Like a quiet library full of untold tales, soil holds memories, but it doesn't speak loudly or with fanfare. It remembers what grew in its embrace, what died upon it, what burned across its surface, what passed through like a shadow. It records footprints sometimes, impressions of steps long gone. It absorbs blood from battles, ash from fires, rain from storms, decay from time. But it doesn't shout history or proclaim tales. It keeps quiet and only fragments, like a shy librarian with selective amnesia or a diary with pages torn out. If you dig with the right tools, patience, and a bit of luck, you might find a story sometimes buried like treasure. But more often you find silence, an empty whisper. And in that silence, we start to realize how fragile a civilization's record truly is, how easily it slips away. We think of soil as surface, mere dirt under our feet. But in many ways it's an interface, a transition zone between living and non-living, a boundary where life meets the Earth's core, where biology meets geology in a slow dance, every fallen leaf adding to the layer, every dead creature returning to the Earth, Every root pushing through like an explorer is shaping the layer below us, and over time, those layers compress under weight, fade into sediment like memories dim in. And if buried deep enough, they become rock, solidified history. But most soil doesn't last that way. Most is turned over by ploughs or paws, worn away by wind, washed out by rain. So traces surviving are rare, precious, and those that do often don't tell much alone, like a tweet without context or a sentence fragment. There are places where soil bears clear signals of past life, like scars or tattoos, ancient hearths leaving char from fires, collapsed horizons showing organic stains from homes, burial sites showing patterns of human activity, discoloration from rituals, disturbed layers from digging, chemical changes from decaying bodies, and offerings left for the afterlife. But those marks are fragile, delicate as glass. Even a few thousand years of weather or farming can erase them, smoothing over like time's eraser. And geologically, they don't hold up unless sealed in unusual, stable environments. Frozen tundra preserving like a freezer, dry deserts mummifying, peat bogs pickling, they slow decay like nature's Tupperware or vacuum pack. This is part of why most ancient civilizations are found through stone and metal, durable materials that stand the test. Information in dust doesn't last without context, and when stripped of that context, detached from artifacts, architecture, or clear stratigraphy, it stops telling a coherent story. It becomes noise or becomes nothing, like a plot without characters or a song without lyrics. Yet research has started developing better ways to read that silence, like learning a new language. Archaeobotany, for example, studies tiny plant remains, pollen grains small as dust, phytoliths like glass shards, seeds, to reconstruct ancient landscapes, what grew where. Geoarchaeologists look at soil chemistry, texture, and layering to infer human activity, like detectives. Black soil layers might suggest controlled burning for agriculture. Phosphate concentrations could indicate habitation or waste disposal from camps. Patches of unusually fertile soil might point to long-term farming or enrichment, but even these clues require interpretation, like reading tea leaves. High phosphate doesn't automatically mean people lived there. Could be from animals gathering. Dark soil could be a hearth or a lightning strike starting a fire. Carbon-rich soil could be intentional like Amazon terra preta, or just wildfire residue from nature's blaze. Without context, without repeating patterns to confirm, those marks don't rise above natural variation. And so, when asking if another civilization might have existed in deep past, we face this reality. Soil won't confirm. Not alone. Not after millions of years. Because even if such a civilization once altered soil, planted crops in rows, built homes of earth, shaped environments with care, those changes are almost certainly reabsorbed, reworked into the matrix, turned over by worms, washed away by floods, compressed, or simply erased. Like editing a document and forgetting to save, or a sand mandala blown away. It's a hard idea to accept that entire societies, knowledge systems, cities of mud and wood, memories woven in stories could vanish so completely that even the soil they stood on forgets them, wipes clean. But that's time's nature. Not cruel, just indifferent, like a river that flows regardless. If nothing resists, nothing remains. And soil as intermediary doesn't resist much. It cooperates, it recycles, it keeps cycles moving, like the ultimate eco-friendly eraser or a compost bin for history. And there's another issue, a tricky one. Even if some residues survive by miracle, how do we know they're not natural? How to distinguish an ancient garden from a wild meadow overgrown? A fire pit from a burned soil patch caused by lightning? A footpath from an animal trail worn by herds? The further back, the less those distinctions matter. At some point, activity and accident become indistinguishable, like blaming every footprint on Bigfoot or every mark on ghosts. We also have to consider that what survives isn't necessarily the most important or telling. Stories don't fossilize into rock. Relationships don't show in core samples like rings on a tree. Songs, rituals, ideas that shaped minds, they leave no chemical marks, no residue, and even when things survive, their meaning often doesn't. We find ancient tools we still don't understand, languages we can't read, symbols we can't decode, and those from civilizations we know existed, like riddles without answers. How much more lost from the unknown? Like a joke without the punchline or a puzzle without the picture. So when sifting soil for answers, we must be honest about what we find and what we're willing to count as significant. A strange chemical spike, an unusually fertile soil band, charcoal in unexpected places. Are those intelligence signs or just noise from nature? The boundary is fuzzy, and in deep time almost invisible, like looking for a black cat in a dark room while wearing sunglasses. But the silence itself is a kind of answer, profound in its emptiness. It tells us that even intelligence, even culture can pass unnoticed, slipping through fingers, that Earth doesn't distinguish between life shaping itself through instinct and life shaping itself through thought and intent. And unless something endures, something durable, strange, clearly artificial beyond doubt, it fades into cycles, just another layer, just another shade in the soil. Perhaps this silence is a reminder that we too might become part of it, a silent layer in the planet's long story, our voices echoing no more. And in today's world, with climate change altering soils, turning fertile land into dust, we're seeing silence spread, where once vibrant landscapes become deserts or dead zones, a lesson that silence isn't absence, but transformation in progress, sometimes tragic. This invites us to reflect. In the face of such erasure, how can we ensure our story endures? Or is that the point, to accept the impermanence and live accordingly, cherishing the moment? Humility isn't something science demands, but something the universe tends to enforce with a gentle, or not so gentle, nudge. Every time we assume we're at the center of it all, we're pushed out, first from a flat Earth at the universe's heart, then from a sun-centered system, then from a special galaxy in the vastness. And now, peering into our own planet's deep past and asking if we're the first to reach this level of awareness and ingenuity, we face another kind of decentering. One that doesn't say we're not first, but gently reminds us we might not know how to tell, like being the last to get the joke at a party or the one who misses the memo. This is the possibility humility offers, that intelligence isn't unique or rare like a diamond, that it could arise more than once on the same planet, and that it could vanish so thoroughly we don't even notice, not because it left no marks, but because we've explained those marks away as natural or never saw them in the first place. Like missing the forest for the trees, or the civilization for the dirt under our feet. We think if something important happened, it would be obvious, bold as brass. But that belief assumes permanence is normal, that history leaves billboards. It's not. Most human history is lost even from the last 10,000 years, erased by time's broom. Whole cultures left no written records, only echoes in oral tales. Whole cities left no visible ruins, swallowed by jungles or seas. How much more could be lost from 10 million years ago, or 100? Like the ultimate cold case, unsolved and forgotten. The geological record isn't a book with neat chapters. It's a puzzle missing most pieces with no picture on the box to guide. And we only notice pieces that contrast sharply with the rest. Something black in a white layer, jagged and smooth, like a sore thumb. The odd stands out. The subtle blends into background, like camouflage in a rock concert or a chameleon at a rainbow convention. This is why the idea of pre-human civilizations is so hard to explore, not because it's absurd or laughable, but because it exists precisely in the space where evidence is weakest and interpretation softest. It requires science to make room for doubt without abandoning rigor or method, to hold space for the unknown without filling it with fantasy or wishful thinking, like balancing on a tightrope over a chasm of maybe, with a safety net of facts. Most scientists don't oppose the idea out of arrogance or closed minds. They oppose it because of training and evidence. Extraordinary claims demand extraordinary evidence, and so far there's none. No smoking gun, no machine parts in Permian rock, no coded messages in carbon layers, no structures, signals, or relics demanding an intelligent source and ruling out all natural. But absence of evidence isn't evidence of absence. It's a gap, not a conclusion. And sometimes the scale of time is so vast that silence becomes the dominant feature. Not because nothing happened, but because Earth is good at forgetting, like a goldfish with amnesia or a hard drive wiped clean. And that's where humility returns, not to surrender, but as a way to stay honest and open. We don't know if we're first. We might never know for sure. And if we're not, we might never find proof. And if we do, we might not recognize it for what it is, like finding a smartphone and using it as a hammer or a mirror. Right now, as we map anomalies, study extinction events, trace chemical signals through sediments with advanced tools, we're limited by what we expect to see. Buried cities with streets. We know how to interpret that. Iridium or carbon spikes. Maybe asteroid, maybe fire, maybe something else like a party gone wrong. But it takes effort to see patterns not already fitting what we've studied before, like spotting a unicorn in a horse parade or a diamond in rough. This limitation isn't just scientific, but emotional, cultural, human. If we accept something like us came before us and vanished without trace, it distorts what we think inevitable. Progress becomes fragile, not a steady climb. Civilization short-lived, like a mayfly. Intelligence less crown and more chance. A fleeting spark. Something that can come and go and come again or not. Like seasons, but with brains and dreams. There's also the meaning question. The big why. If there was someone before us who built societies, dreamed of stars, wondered about their place, failed in ways we can't know, what does that mean for us now? Does it make us less special or more connected to a chain? Are we their continuation or replacement? Echoes or reboots? Do we repeat their mistakes or walk new paths they didn't? Learning from invisible lessons? We don't know, and that not knowing is part of the point, the beauty. The possibility the most enduring legacy of a prior civilization isn't material or tangible, it's conceptual, an idea, that we might not be first and that one day someone might ask the same about us. What will they see looking back? Carbon mutations, plastic scatters, a short flash in sediments. Will they call it civilization? Will they call it tragedy? Will they call it proof they're not alone, or just a blip? We imagine the past fixed, set in stone. But it's not. It shifts every time we look from a new angle with new tools or new questions, like a painting that changes in light. And this question, the one about lost civilizations, isn't really about the past. It's about how much unknown we're willing to live with, embrace. How much wonder we're ready to embrace, like a child asking why endlessly. And perhaps, in that uncertainty, we find freedom. Freedom to dream of lost worlds and coming ones, to explore with open eyes. Because humility isn't weakness, but the key to unlocking the universe's endless possibilities, where every mystery is an invitation to explore further, and every silence a space for new stories to emerge, new chapters to write. So here we are at the quiet edge of the question. After all the plunging, all the wondering, all the long descents through, horizons, echoes, and the occasional joke to keep things light. And perhaps we're left not with certainty, but with stillness, a pause in the cosmic symphony. And in that stillness, something light happens. The question softens not because it's answered with finality, but because it's heard, pondered, and allowed to linger like a good melody. We might be the only world, or not. Complexity might be rare, a cosmic diamond, or perhaps elusive, hiding in shadows. Perhaps it blooms in hidden folds and fades before leaving marks, like flowers in the night. Perhaps black holes bear more realms than we'll ever know or count, each flashing into structure, shaping their gravity, then slipping silently under the next curvature, like guests who leave early without saying goodbye, but leave the door ajar for others. We search because that's what minds do, not just search, but reach across voids, across horizons, across possibility with arms outstretched. Curiosity is like sending thoughts to other realms or probes into the dark, asking if anyone else might have dwelled where we dwell now, looking out, wondering, listening, perhaps even laughing at the absurdity. And you, right now, wherever you are, whatever time it is, maybe under a blanket of stars or the glow of a screen, you're part of that, part of the long thread tying questions to silence, and silence to theories, to stories. Just by listening, by following this thought trail through the voids and laughs, you're engaging in something deeply cosmic, or perhaps not just cosmic, perhaps universal, perhaps multiversal, a shared experience across realities. Because rest is a kind of deep gravity too, releasing the surface, sinking into layers of dream and subconscious. And as you drift off tonight, you'll enter a space not so different from what we have explored. Quiet, vast, not lit by certainty, but by possibility. And perhaps, just perhaps, minds that nested before, if they nested, will meet yours in passing, not with answers, but with companionship, a silent nod. So rest now, not because the question ends, it never truly does, but because you've carried it far enough for one night. Through laughs and wonders, the interiors will wait patiently, the cosmos will keep curving whatever dwelled before, whatever dwells after. You're here now. Good night, horizon crosser. And when you wake, perhaps you'll look at the night sky with new eyes, wondering if it's whispering hidden secrets or not. Because in deep gravity, everything connects, and our journey is just a thin layer in the endless canvas, where each new layer is a chance to write the story onward, inviting us to add our own chapter with care, wonder, and a touch of humour.